So now we're going to talk about a finance example. And in the finance world, they have this concept, it's called marginality. And they apply it to just about everything. You talk about marginal cost, marginal revenue, marginal profit, marginal utility. And what it means is the cost of producing one more item. Right? So let's, or the revenue from one more item, the profit from one more item, whatever measurement it is you're talking about. So I have here just a very, very basic function for us to work with for an example. This is f of x. Excuse me, got a little messy. This is f of x equals x squared. And just to make this concrete, let's say this is our cost function. Okay, so I can see here from my graph, or because I know the formula, the cost of producing 1 unit is, and again, let's keep it simple. Let's say that this is dollars. Right, so the cost of producing 1 unit is $1. And I want to know, what is the marginal cost at this point? Right, well, the marginal cost is the cost of producing one more item. Right, so let's see, the cost of producing that second item is going to be 4. So the marginal cost is the difference. It's the difference between the cost of producing 1 item and 2 items. So here it would be 3. And let's just do one more just kind of to get the concept. Let's say we've produced 2 items and we get an order in. I need to produce a 3rd item. I want to know, what's the marginal cost? How much more is it going to cost me to make this 3rd item? Well, the 3rd item, that cost is 9 units. So the marginal cost here is the difference between 9 and 4, which is 5. Okay, so I want a formula, right? I want to come up with a way to tell people, what is the marginal cost at various points in the production process. So let me clean up here. And let's see how we can do this. Okay, so let's take a look, right? Let me, because you want to make this a calculus thing, right? So let's say we're here at 1, and I want to know the amount that the y changes going from 1 to 2. Okay, so that's going to be this distance here. Now, here's what I'm going to do. Because you want this to be a calculus thing, right? I'm going to draw the tangent line at this point. All right, and here's what I want you to notice, right? I want you to notice this distance here, this delta y, is really close to this distance here. So what we're going to do is we're going to use this delta y. We're going to use this amount that the tangent line changed as an approximation of the marginal cost. And unless your function is weird, unless it's changing really, really quickly for some reason, this is actually going to be a pretty good approximation. So how can I do this? Well, look, what is the slope of this tangent line? Well, this slope of this tangent line is f prime of x. But remember what I'm looking for. I'm looking for this delta y here, right? Okay, well, if this distance here is delta x, then f prime of x, the slope of the tangent line, is equal to delta y divided by delta x. But remember, we're talking about the marginal cost here. That delta x is always going to be one item further over, right? The next item. So delta x, when referring to marginal cost, is always going to be 1, which means delta y, which is what I'm looking for, which is my approximate marginal cost, is going to be the derivative at that point. Right? So what I want you to take away from all of this, right? Anytime you hear marginal cost, right, I want you to think, okay, I'm looking for the derivative of the function, because that's going to give me a really good approximation. Okay, so I've got an example here, and we are talking about costs, right? The cost function is given by this formula, right? And I want to know, what is the marginal cost of the fifth item? Well, I know that, let me just write it here. C of x is x squared plus x plus 1,000. So C prime of x is 2x plus 1. And I know from our previous conversation, the marginal cost of producing the fifth item is C prime of 5, which is 2 times 5 plus 1, and that's 11. Right, and we're talking about cost, right? So my units here would be dollars. Okay, so we've got multiple functions this time. So suppose the cost of producing X units is this function, and the revenue is this function. So I want to do three things. I want to find the marginal cost. Let me write them here. Marginal cost. I want to find the marginal revenue. And I want to find the marginal profit. Okay, well, I have functions for the cost and revenue, so that's just a question of finding their derivatives. The marginal cost is the derivative of the cost function. That's 2x plus 1. The marginal revenue is the derivative of the revenue function, which is 125, and that kind of makes sense, right? If the price is constant, then the marginal revenue is going to be constant. And finally, the profit. Okay, here we're going to have to work a little bit. How do you determine the profit? Well, the profit is your revenue minus your costs. Okay, now you could put 125x in here for the revenue and x squared plus okay, right? And find an actual function for the profit, but I wasn't asked that. Look, let's apply one of our derivative rules. Let's just differentiate both sides of this thing. If I do that, p prime of x is r prime of x minus c prime of x. And I already know what those two derivatives are. R prime is 125, and c prime is 2x plus 1. Be careful, you notice the parentheses I added there, right? So I'm subtracting the whole thing. So this is 125 minus 2x minus 1, which is 124 minus 2x. There's my marginal profit. So in the next lecture, we're going to continue thinking about business-related examples. We're going to see how the derivative can be used to describe something economists call the elasticity of demand. It's a measure of how sensitive the demand for a product is to changes in the price of the product.